Alright, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. This is using the Squeeze Theorem to find the limit of each of the following sequences. So, a sub n is equal to sine n sine 1 over n. I think that sometimes math professors are actually secretly sadists. Like, maybe not all, like not all of them. I'm trying to like blanket statement here, but I think that could be a thing. I just like enjoy watching other people suffer. They're like, oh, I'm gonna make this math problem. It's gonna be so terrible. It's gonna make kids cry. I'm gonna watch them cry. Okay, so let's go ahead and check this out. So one way to organize all this is to use a t-chart, and that's what I've done in the last videos as well. So if you haven't seen 42, 41, 40, 39, 38, 37, one of those other numbers before 43, go check them out, because yeah. So I'm going to use S again because I liked using S in the last video. S is for supra, which is the Semper Supra is the slogan of the Space Force, which means always above. Thought that was really cool. It's like a play on words. It's like, haha, we're the Space Force, so we're always above you. All right. A sub n, B sub n for below, just B for below. That's not. Just didn't really put a lot of thought into that one. Okay. So if they don't say what n value to start at, we assume that we're starting at 1. Boop, 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 boop. So I'll probably just round to like 1 decimal place maybe, but I'm thinking that this is probably going to go to 0. It just kind of has that vibe. Because sine of 1 over n is approaching 0. Like 1 over n is approaching 0, and then the sine of 0 is 0. And then the other thing is just oscillating, like sine n is just oscillating. So it's like this oscillating thing times a number that's approaching 0. So it looks like it's going to be 0. We'll do a couple. 2, maybe 3, and then infinity. So it looks like it's going to be 0 just because it does. Let's make that a better looking 0. That looks better. There we go. Okay. So, I might just go ahead and start typing stuff in. I wonder if we can get away with using the same aboves and belows as last time, and the time before that, actually, as well. We might be able to. I'm going to go ahead and type this into Desmos, and that way we can look at these values. But if you're not able to use a graphing calculator, that is okay. Get out of here. That is okay if you can't use a graphing calculator, because you can just type in the values into a scientific calculator. If you can't use a scientific calculator, if you have to do this by hand, you need a new professor, because that's insane. That's just too much. That's just too much. So sine x times the sine of 1 over x, and I'm using x just to be kind of safe. I know Desmos is usually fine with using other letters besides x, but I just like to keep it safe. Keep it secret, keep it safe. Why is it not liking this? I don't know. Because I'm not timesing it? Maybe that's better? I don't know why it's not liking that. Why is it not liking this? I don't know what's up with this. Hold on. There it goes. Okay, just didn't know. It just didn't know what I was trying to do there. It thought maybe I was trying to do like the sine of 1 over x, maybe. There we go. Okay. So now it likes me. And so I kept these in here from last time and the time before that, actually. And it looks like these work out pretty well. If the limit is going to 0 as you go to infinity, like the limit as in goes to infinity of a sub n is 0, or you think it's 0, then 1 over n and negative 1 over n actually have been coming in clutch for me here. And it looks like this works out really well, because check this out. It scrapes it. We have like tangents. It's tangenting. It's tangential. That's actually a word. As it goes to infinity. This is really cool, actually. I'm totally nerding out right now. So it's staying in those parameters. And now, in order to prove that definitively, you would need to say, let's set a sub n less than or equal to s sub n, which is 1 over n, and then prove that it's always going to be less than or equal to for all n values that are natural numbers from 1 to infinity. And then the same thing for the other one, but the other way around, right? So we would need to prove all of that. And if you have trouble with that, let me know. I'm not going to get into that too much in this video, but I will show you a couple values, and hopefully a t-chart will be fine. So let's look at a couple of these values. The S sub n and the B sub n will be pretty easy to calculate, so I'm not going to need to calculate those. But what I might do is go ahead and calculate a couple values here. So I'm actually going to yank this over here and type in f of 1. Now you can do this on a not graphing calculator as well. So you would just type it in manually. You would say the sine of 1 times the sine of 1 over 1, or just the sine of 1 times the sine of 1, and then your scientific should be able to split out the answer. Make sure you're in radian mode, because if they don't say what mode we're in, then we're defaulting to radian mode. So it's about 0.7. I'll go, can I squeeze it in? No, let's just do 2 decimal places, so 0.71, because it's like 0.708, blah, 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 blah. We'll go 2 decimal places for this. So f of 1, f of 2, 0.44. And we're just doing this so that we can show that the values are always above or always below for all in. And if your professor needs to see more of these values, then just show them more of these values. But I'm just giving you a little taste of what this might look like. And hopefully your professor likes this as an answer. The 1 would just be the 1, and the negative 1 would just be negative 1. And then 2, remember S sub n is 1 over n. So it would just be 1 over 2, which is 0.5. And then this would be negative 0.5. Right, so 0.5 is above 0.44. We're still safe here. And then 3, that would be 1 over 3, which is 0.3 repeating. I'm going to round to 2 decimal places for all of these. So that's going to be 0.33. That's going to be negative 0.33. There we go. Still working. And then as we go to infinity, that's going to be 0, and that's going to be 0. So if your professor needs to see just more values in a t-chart, this would actually be a really great way to do it. Have the S above the A and have the A above the B. It's just nice and neat and organized, and I think hopefully they like that. If they need to see more work, like I said, let me know if you get stuck on that, and just give me as much detail as you can in the comments, so that way I can figure out like what they're looking for an answer, because not all professors are on the same page about what a proper answer is supposed to look like. It is what it is. So at this point, we're basically done. We would just say B sub n is less than or equal to A sub n, less than or equal to S sub n, for all in, and that would be ins that are natural numbers, by the way. You could also say that they're positive integers, and that would be fine. Sometimes they like to say positive integers, but positive integers and natural numbers are actually the same thing. So it would just be better to write. It's simpler to write it that way if you need to have a little bit more nuance or whatever. I don't know, whatever. So that's part of the equation for squeeze theorem. And then the other part would be to say that the limit as n goes to infinity of b sub n is equal to the limit as n goes to infinity of s sub n, which is 0. Therefore, when you do the little 3 dots right there, it means therefore. Therefore, the limit as n goes to infinity of a sub n is also 0. And that's more or less the squeeze theorem. That's almost completely by the book. I'm usually not a complete by the book kind of person. If your professor needs you to be, then just give them a little more detail. But that's basically what you would write for an answer. And that would satisfy, I would say, at least like 80% of math professors. So if you have one of those other 20% and you're still in drop week, maybe it's time to drop your professor and find a better one. Otherwise, you can do it. Stick it out to the end. And I'll catch you in the next video. Yeah. Oh, check out the 5 math mistakes everyone makes and how to avoid them. That is a free PDF guide I had on my website, myersmathematics.com. And that link is in the description below. Catch y'all in the next video. Blessings, y'all.